Good morning, everyone, and thank you for joining us for the first webinar of our 2022 Associate Member Webinar Series, The Benefits of Ultra-Low Permeability Concrete, brought to you by RCH Building Accessories with Specialty Products Group. We are pleased to be able to bring this series into the new year to continue to showcase our associate members, their products and services, and the opportunities they present for the concrete industry. My name is Tracy De Silva. I'm the office manager with Concrete Ontario, and I will be your facilitator today. With me, we have Oliver Zhao, our technical services engineer, who will be running our question and answer period immediately following the presentation. And now I'd just like to quickly go over a few housekeeping points. The presentation itself will be approximately 40 minutes with a question and answer period at the end, followed by a Kahoot pop quiz with some great prizes. So you may want to stick around for that. All participants will be muted. If you do have questions, we encourage you to use the questions pane in the GoToWebinar, and Oliver will address those at the end of the presentation. The webinar will be recorded and posted on the Concrete Ontario website along with a PDF copy of the presentation. And now I would like to introduce to you today's presenters. First, we have Rob Hedges, manufacturer's representative with RCH Building Accessories. RCH Building Accessories is one of the newest associate members with Concrete Ontario, and we welcome them and Rob and look forward to learning more today. Joining Rob, we have Scott Bergsbakken. Scott is the president of Specialty Products Group. Scott was a committee member for the Strategic Development Council for ACI and a director for the Northeast Regional CSI. Scott has wide-ranging experience in the commercial construction industry and has been a special design construction consultant to several Fortune 500 companies. Scott is the immediate past president of the Hartford CSI chapter. His broad concrete knowledge and specialized training combined with extensive experience make him an industry expert. Scott has presented technical information to many national organization meetings such as ACI, USGBC, and CSI. Thank you so much for joining us today, Rob and Scott. And Scott, now I'm going to hand the controls over to you.
Thank you, Tracy. And that's my beloved dog, Gus, who's now 14. I'm in a hotel room with somewhat limited internet situation, so I'm going to turn off my webcam. Probably all happy about that. Fix that. Lost the screen. All right. So today we're going to bring you a product that's been in existence more or less in its present form for about 50 years. And when it was originally created, it was used as a waterproofing material, admixture, waterproofing admixture in the concrete, and a workability aid. And about 20 years ago, give or take, we discovered that this solves the moisture and flooring crisis, and things have really amped up since then. And we've also found a lot of new uses and methodologies for it. So that's what we're going to talk about today. Portland cement, 75% of it is tri- and dicalcium silicate. When those silicates react with water, they form calcium silicate hydrate. This is the building block of concrete. This is what gives you your early and long-term strength. It also forms calcium hydroxide, which doesn't bring a lot of positivity to the completed matrix of the concrete. And this is primarily what we're here to talk about today, is the free water or water of convenience in concrete. And by the way, I'm American and hopelessly American with the metric system. So Rob will help me out here as appropriate. Where when you guys make a cubic meter of concrete, and Rob, I'm not sure that translates directly, so we better hold on, bear with me. Oh, all right. So when you make a cubic meter of concrete, you start out with give or take 160 liters, which I think is probably inaccurate because Rob didn't multiply it by 1.3. But anyway, the point is that less than half of it is being used in the chemical reaction with the Portland cement, leaving you more than half of it just sitting in the concrete. And that water is there to facilitate mixing, pumping, placing, and finishing. And once it's completed that function, it sits in the concrete and really ultimately becomes an enemy of many things involved. When concrete is placed, the heavier materials settle to the bottom. So the aggregate goes toward the bottom, and the lightest material in concrete is water, that jumps in behind the stone and goes up and creates bleed water on the top of the concrete. In this process, bleed channels are created. And these bleed channels provide a route of moisture vapor leaving the concrete, causing problems. So if you could close those channels, never allow them to occur, you'd have a near perfect building material. You could also solve this problem. That's a floor getting blown off by water coming out of the concrete. You could also help with some of these issues. You think about exterior concrete and having an open capillary system like that, being porous. It's going to take in water. You're going to have freeze thaw. You're going to have salt. This became a giant problem in 1999 when the U.S. EPA lowered the allowable VOC limits inside the building envelope. A lot of things were problematic with that, but flooring adhesives were at the top of the list. Previous to this law passing, flooring adhesives have been solvent-based. In order to comply with this, they had to become water-based. And you folks are in the same position up there. And every single one of your schools and your healthcare facilities has a problem with moisture in concrete. And what we're here to do today is to help you transfer the money from the current flooring contractor who's solving this problem topically into your pocket while helping your concrete as well. That's the second floor of a building. That's just free water coming out of the concrete. So what happens in the commercial construction process is that when they get ready to install the flooring contractor comes out and performs these tests. If they were to pass these tests, they would then install the floor. About 65% of all commercial projects and close to 90% of healthcare projects do not pass these tests. So they have to go through a process of topically treating the floor, which involves bringing in a shot blaster, a bead blaster, to put a texture on the top of the concrete. And the reason they're putting the texture there is because the next step is to put this epoxy down. And the epoxy slows down the rate at which the moisture leaves the concrete. Doesn't stop it, slows it down. Think of like a toll booth, cars streaming in and then trickling out. That's what it does. But the reason that the concrete needs to be textured is because this has limited adhesive qualities. So they want it to get a good bite into that. Then they self-level on top of that material because flooring adhesives won't stick to it. And then they install the flooring. So the problem with this is multifold. In your region, you're about $100, well, $10 a square foot. So help me with the math on that, Rob.
Oh, yeah, I've had $10 a square foot, so times 3 in that range, right. A bit.
Yeah.
Or 9, actually. Yeah, 3. Yeah, 3. Times 3.
Anyway, it's expensive.
Yeah.
It's excessively expensive. And the admixture that we're going to talk about shortly is in the $1.50 range to the end user. So it's an obvious bonus for them. This is a project UNC Rex Heart and Vascular Hospital. We've done thousands of schools and hundreds of hospitals and probably thousands of MOBs. So this building, 28,000 square meters. When the finishers left the space, it had 243,000 liters of water sitting in that concrete, the free water, waiting to come out. And when does that water come out? Well, after they close the building, put the windows and doors in, and they turn the HVAC on. Inside that slab, it's pretty close to 100% relative humidity. When they air condition the space, you get down to 50%, and it's going to pull that moisture out because it wants to equalize. And that happens, they turn on the HVAC 10 minutes before the flooring installer gets there, right when it's at its height. And if the slabs were 6 inches, 364,000 liters. Concrete drying times are 40 days per inch of thickness under ideal conditions. Ideal conditions, doors, windows, HVAC running. Then you get 40 days per inch of thickness. So a 4-inch thick slab, it's 160 days after you turn the HVAC on. They never, ever, ever have that kind of time. So that's why a lot of jobs have that topical treatment. And alternatively, the solution we're bringing to you may be the way to go, hopefully. So remember, our 75% tri and dicalcium silicate react with the mixed water and form calcium hydroxide. While our VaporLock 2020 liquid concrete admixture reacts with the calcium hydroxide in the free water to form additional calcium silicate hydrate gel. This is the same chemistry used by fly ash, slag, silica fume. It's just that ours is more controllable and predictable. So we've arranged a demonstration here, a video demonstration. And please understand that what we're about to show you is 600 times what we would put into your concrete truck. We don't increase setting time at all. It's within 1 minute with or without VaporLock in it. So what he just did there was put water in, Portland cement, water. That's going to be our control sample. And over here, this is water, Portland cement, and VaporLock. Again, 600 times what we put into your truck. We, on average, you put about a 5-gallon bucket into a full truck. So this would be 300 gallons. So it's going to set up quickly here. The point is to show how we react with the calcium hydroxide in the free water. Come on. See over here, all this water causes problems. Right? So what happens with VaporLock in there is we react with calcium hydroxide, which is a good thing. We're taking that out of play, and the free water to make more of what makes concrete strong. And a lot of benefits spring from that. Think about that. This water here is still inside here. So what we've done, partly by accident, is create an internal wet curing mechanism. A lot of concrete people, QC managers, things of that nature, like to use VaporLock just for this reason, because having the jump up of having internal wet curing provides them with a better quality finish and situation than they would normally receive. This is a hospital we did in Houston. It's a million. It's 1 million square feet. And they use VaporLock in every floor there. They also used it on the roof deck, which is a story unto itself. But they spent about $750,000. This is American. $750 to put the vapor lock in there. It cost the ready mix provider a little less than $400,000. So this building over here, same ownership, different architect, different GC, did not use vapor lock. That building is here, same size. They were 9 months behind, and this was one of the reasons stated. They spent $3.5 million treating this building topically. They also put 100,000 man hours into it to do that. And while they have the wet epoxy and those things about, other trades can't be in the space. So it's dramatic. And by the way, 7 days after this roof deck was poured, we gave them the go-ahead to glue down their roofing material. And 3 days after that, Hurricane Harvey popped into town. This is Houston on the waterfront, and that roof is there to this day. Sorry, I'm a little hoarse. I'll take a drink of water here. So the vapor lock reacts to calcium hydroxide in the free water. And this slab is now impermeable. These gray bleed channels won't be there. And if this was your garage or your basement floor, you could take a cardboard box, put it on the floor, put, important photographs or business documents or whatever into it, put a brick on top of it, and you could come back a year later and pick that up, and it will not be damp on the bottom. When we do a project where they're installing flooring on top of slabs that have been enhanced with Vapor Lock 2020, we provide a warranty 10 years. If that floor comes off in any way moisture related, labor and materials to repair that floor. And as far as I know, unique to the commercial construction industry, whenever we issue a warranty, Lloyd's of London issues a third-party insurance policy direct to the end user underwriting our warranty. So if for whatever reason we couldn't fulfill the obligation of fixing that floor, made too big, whatever it is, Lloyd's is backing up our policy to the tune of $20 million Canadian with no aggregate. So each and every project our warranty is insured to the end user and naming each and every one of you as additional insured. So if somehow you got dragged into the mess, we would even handle your litigation, Lloyd's would. So that's a pretty powerful thing, and that's a risk management tool without comparison, I believe. We have an extensive quality process because we want to be successful, and being successful means not having any failures. We have just short of 3,000 jobs out there over our 12-year history. And when all of our quality steps are followed, we have a 100% track record of success. So the supplier, the ready mix person, we certify them. And the certification process is you read 2 pages of info, you take a 5-question test. Our head of technical will call you up and have a chat. The big thing for ready mix people is you just don't put vapor lock, you put it in with the head water. It goes into the water. That's the trick. And for the finisher, he shouldn't be waiting for bleed water. We want to look at the mix designs just to make sure, we're in our sweet spot. And I know that the Canadians are a little slow on that. We can live with cement content and W2CM. We take cylinders and we have them tested. They hydraulically push water through it. And we want to be on the job, by the way. So let us know, hopefully in advance, that you're about to work with some vapor lock, so we can take that cylinder and get it tested. We do moisture bond and pH testing when it comes time to install the flooring or the roofing. We give them an authorization to proceed, and then that warranty you saw is issued, upon completion of the project, and the Lloyd's policy as well. Additionally, we developed these products here, and this is what we call a gateway that sends information up into the cloud. And the information it's sending is right here. So this is a temperature and humidity sensor, which puts the information into here and shoots it up to the cloud. So we can monitor projects in real time and make sure that they're within the appropriate temperature and humidity range. So there's something wrong here that they're at 18% humidity. There's some kind of a problem here with what's going on. So we would say, hey, slow up. If you put in flooring when it's too cold, and then when it gets warmed up, it expands, it's going to pop off the floor due to its expansion, right? So we avoid that misstep with this system. These are some of our projects just in the U.S. Like I said, we're coming up on 3,000 projects. I think that we have roughly 100 projects in Canada. A lot of them centered in Saskatoon, Calgary, and I think about 10 projects and several schools up in the Toronto area as well. But this represents reasonably close to 50 million square feet of flooring with a 100% track record of success when all of our quality steps are followed. That's a big statement. So by closing off the capillary system, we waterproof concrete to a high degree. Outperform crystalline growth pretty dramatically. We have NSF 61 approval, so you can use it in potable water applications. And the internal wet curing system virtually eliminates shrinkage, dry cracking, slab curl, all the associated negative things that happen when the free water leaves the concrete unevenly. It acts as an SRA and reduces ASR by 53%. And because it's a closed capillary system, durability and resistance to freeze-thaw are dramatically improved. Reduce the heat of hydration in mass concrete placements by 8%. That is, to be fair, though, an in-house test. No need for sealers on the concrete to stop dusting because we've closed the capillary system, so dusting not required. And for reasons that we've been unable to ascertain, our FF and FL numbers are off the charts good. We're not 100% sure why. We haven't figured it out yet, but they are. And we manufacture VaporLock 4040 as well, which is a VaporLock, same as 2020, except that we've added an additional element into it. It's a phosphate we've taken from the medical industry that when the concrete is in the plastic state, it will migrate to the steel rebar. It'll cover it with an invisible coating, and you won't have any corrosion issues. Even if that concrete's cracked and it gets exposed, short of abrasion, it won't rust. So what you have here is a product that waterproofs the concrete, handles the corrosion, and acts as an SRA in one shot. And you have no calcium nitrite in it. So the workability issues that are sometimes associated with that are not there. An interesting thing about that is that you'll notice when you're working with the CNIs that the numbers move, depending on how long you want the structure to stay. In America, it's 3 to 5 gallons per cubic yard. When they're at the 5-gallon side, they're looking for 100 years. And what's happening there is that the calcium nitrite, when it does its job and reacts with the atmosphere, it becomes calcium nitrate and is no longer effective. So in reality, it's a sacrificial coating. And I would encourage you to take a hard look at our corrosion control system. Here's VaporLock, and VaporLock with lightweight concrete. Lower is better. VaporLock 4040, great workability. It's a permanent solution. It protects the steel, waterproofs concrete, internal wet curing agent, VOC free. VaporLock 2021 and 4041 are waterproofing agents. They are NSF approved, extreme densification. We provide an exterior warranty against spalling as well. If you get a spall larger than an inch, we'll supply the repair material to fix it. So crystal growth materials, here's a comparison. There's a control, crystal growth, 3.6 months, 7.2 months. So in line with their claims, they double the waterproofing capacity of concrete, whereas in our case, we're at 250 years. When we take a cylinder from the project, step one is we send it off to an independent lab and they pump water through it hydraulically. That's our first quality step. And we want to take a look at that and make sure that it's impermeable to an appropriate degree. And usually we're looking at, 3,000 to 5,000 years it would take water to go through a 4-inch thick slab. We make a variety of other products. If you guys have any interest in it, we make this spray-on material here that they're putting on the coke pile. You can seal any pile you have with this material. It's waterproof. It's a naturally organic material. It's renewable. Any interest in that, let us know. That's where I'm at. Rob, you must have something to add to this. All right.
Sorry.
How do we get? Yeah,
yes,
go ahead.
This past summer, we've done some 4 or 5 schools. We've done barrier walls on bridges. I'm anticipating in the coming year, we're going to be doing a small water treatment plant, all designed to create permeable concrete to create sustainability on these projects so that they're going to be in place until the owner decides to knock them down. It's a great product for sustainability, permeability as we've gone through. And it's a product that's not as widely used here in Ontario/Canada, but I see it coming on strong, and with all the benefits that Scott's gone over versus other crystalline products, I can see this product becoming the #1 product in the marketplace. So I'm excited about being part of it. If anybody has any interest in more info on this, I work out of my home office here in Cambridge, Ontario, and I'm accessible to anybody at any time who may want to chat about the use of VaporLock going forward. And
by the way, we manufacture in Smithville, Ontario.
That's right. It's close, very close.
And Rob, if you could maybe share the experience that the Ready Mix people had with VaporLock in that area, that would be good too.
Yeah, this past summer we did 4 warranty jobs, all in schools. I would arrive at the batching plant on the day of the batch. We would go over what's going to happen. They'd give me a test. Everybody was very happy that it did not affect any of the application or the mixture of the concrete. When we moved over to the job site, the applicators had no problems putting it in, finishing it. The bleed water, I warned them about there'd be no bleed water, and they were fine with that. And at the end of all of the projects, they said it was just a dream to finish off, and they thought it was a great product. So all of the jobs that we've done, we've had nothing but positive reactions to here in Ontario. And like I say, I see it growing in leaps and bounds in the future.
And there isn't any significant bleed water, but what there is extra cream to work with.
Yeah.
So the finishers enjoy using that extra cream. It's just, it's a beautiful thing. And I'm the president of the company. And if there were any problems, finishing problems of that nature, I would have heard about it. And there aren't.
Yep.
Everybody loves it. So Oliver, how do we handle questions here?
All right. right. So thank you so much, Scott and Rob, for the presentation. I got a few questions coming in here.
Nice.
Most of them are quite technical. First question, what is the ASTM designation for this admixture? Is that type S?
Yes. ASTMC 494 type S.
Okay. And what is the shrinkage reduction on a, for example, 25 MPa mix for floor slab?
So could you repeat that question, please?
So what is the shrinkage reduction using this product on a standard 25 MPa floor slab mix?
Yeah, I don't know what the exact number would be. All I can tell you is that the shrinkage is improved and it outperforms a shrink reduction admixture on average.
Okay.
We can get you the specific numbers, Rob. We have them? I just don't have them, right? So.
Is there any training or is there any training that's needed before you apply this product to concrete producer with the floor finisher before we use it?
Yeah, so we want to talk to everybody just to make sure, everybody's playing on the same board. We want ReadyMix to put it in with the headwater. And by the way, we're happy to supply dosing equipment and hook it up into your system so it can show up in the batch ticket. We'll help you get it in there. We make our own batching equipment in-house and we'll install it, no problem. But we want to be added into the headwater. And regarding the finisher, he just needs to know really not to wait for the bleed water. And I can promise you this because, I've been on hundreds of jobs, probably more. And once you get a finisher, finishes a job with vapor lock, the next time it comes in his way, he's smiling. And ReadyMix should be smiling too, because you're going to make, give or take 15 to 20 bucks a cubic meter by putting vapor lock in there.
Okay, great. One question on the online platform that you showed us on the presentation. Does the contractor or the supplier has individual access to it? And if they can send maybe some report through the platform directly, pull out a spreadsheet, for example?
We will provide individual access to it, directly to it. We'll give you a username and a password. You're talking about at the end there when I showed the app for the, we provide direct access to everyone who wants it.
Okay, great. One question on the video that you showed us, the chemical reaction was quite dramatic,
aggressive,
because of the big dosage that you have used.
Yeah.
So at normal dosage, what is the impact on the slump loss and the setting time for the flooring contractor?
So as part of getting the ASTMC 494 type S testing, they have to test for set times. And we were within 1 minute of control. So there isn't any dramatic effect on set times. Going back, we put a 5-gallon bucket into a full truck. That was, and I can't remember, it's either 300 gallons or 600 gallons, by ratio. So they've never set up that fast in the real world.
Okay, great. And Rob, you were mentioning you did some project locally here, and can you just maybe provide a little bit more detail on how the product did improve the performance?
Improve the what?
The performance of the concrete, yeah, and maybe just a little bit more detail on the project.
Yeah, so what the projects were, basically they were, the majority of them were school gyms, and some entranceways where tile was going down. And the vapor enhanced concrete, the vapor lock went into the concrete at the batching plant. The application at the batching plant was simply dumping it in with the head water and then mixing it, and there was minimal steps involved, different than what they were doing other than the adding of the vapor lock. When we got to the job site with the product, the flooring guys, the finishers, really just seen no difference to the regular concrete they have. The biggest performance enhancement that they get is at the time of finishing. They can get on it. They don't have to wait for the bleed water, and when they do finish it, they have, as Scott had mentioned, they have that nice cream that's on top, and they just that just enhances their experience with the finishing side of it. But as far as enhancing, that's the biggest thing, is the finishing. I think the true test is that there is not a lot of difference in the handling and the performance of the concrete and other aspects of it. So, which is,
Well,
go ahead, Scott.
I was going to jump in there with a couple things. I mean, overall, workability is improved. I did a project that was a 5,000 PSI mix, so very strong. And they were doing grade beams with that mix and then pouring a slab on top of it same time. And they did not put vapor lock in the grade beams, but they did in the slab that was going on top of it. And the one pumping the material with the grade beams was using 25% more pressure to pump that concrete than the one doing the slab. And we talk about workability. Pumpability is a big function of workability. We've done hundreds of lightweight jobs where they're pumping up 3, 4, 5 stories, whatever it is. Never had a complaint. And we asked the pumper, what do you think? He scratches his head and goes, you know what? I didn't have any problems all day. So some things are pretty subtle, but overall workability is improved in every phase. Sorry, Rob.
That's okay.
Awesome. Thank you so much, Rob and Scott, for the answers. I'm going to hand back to Tracy for the quiz.
Thanks, Oliver, and thank you so much, Scott and Rob. That was an excellent presentation, and I hope that everyone was paying attention, because we are going to move into our Kahoot Pop Quiz now. We would ask everyone to please use your smartphone to access the following website, www.kahoot.it. Shortly, I will show you a pin on the screen, and you can enter that. You will be prompted to enter your email address. So if you do win, we can send you a prize and a nickname. And please remember, we are a family-friendly show. Please use something your HR department will approve of.
So can I compete too?
I played against you yesterday.
All right.
The faster you answer each question correctly, the more points you will earn. And our prizes for today are Amazon gift cards. First place, $150. Second place, $100. And third place, $50. So you'll want to have your thinking caps on, and I will show you the pin now. It should be on your screen. Again, it's www.kahoot.it. Enter your PIN, email address, and a nickname, and we'll get started shortly.
This is a nice thing you guys have discovered here.
It's
a
really good tool.
Yeah.
I like the names.
Right.
Give it another minute or so.
So how's your weather up there today? You've been having some snow recently, huh?
It's a little gray today, but not too bad in terms of the cold, so we'll
Yeah.
take it.
Yeah. I'm not too far from you in Rochester right now.
Oh, right.
Yeah.
Okay, I think we might as well get started. Hopefully everyone's ready. In 3, 2, 1. How many liters of free water is not used in the curing process of the concrete? $82 liters. And we've got one correct answer. By concrete, go. Question 2. What percentage does vapor lock outperform other crystalline products? %500. 2 correct answers. Let's see where we go from here. Concrete Go, still in the lead. Semi-retired me, moving up. Question 3, true or false? Vapor lock should be added with the headwater. Well done, everyone. It is true. Concrete Go, on fire. Next question, true or false? Vapor lock chemically reacts similarly to an SCM. Split. The answer is true. Semi-retired me takes the lead. Moving on, question 5, another true or false. Vapor lock corrosion control is not permanent. And that is false. And where do we stand now? Concrete Go. Back in the lead. RCV's moving up. Question 6, true or false? Vapor lock is dosed at 650 milliliters per 100 kilograms of Portland cement.
To be fair, I don't know that we covered that thoroughly, so this is a guess.
It's true. 50-50
Sorry,
chance.
guys.
And RCV is now in the lead. A close race. Question 7, true or false? Vapor lock enhances concrete waterproof. And that is true. Still RCV at this point. True or false? Vapor lock does not carry an exterior warranty against spalling. The answer is false. Semi-retired's moving up. Still RCV. And this is our last question. Blank of dollars were spent each year to resolve flooring issues before the introduction of vapor lock technology. Millions, trillions, or billions? Again, split, it's billions. And let's see where we landed. In third place, Concrete Go. In second place, Semi-Retired Me, and our winner in first place, RCV. Well done, everyone. Thank you so much for playing. We will email out the certificates very shortly. You should see them a little later on this morning. So thanks again for playing. And we would ask that you join us for our next webinar on March the 17th, again at 10 a.m. And our associate member presenter will be Concreation. We would like to thank Scott and Rob again, and everyone for joining us this morning. That was a great presentation, and we look forward to many more throughout this new year. Until then, we appreciate everyone's participation in these Concrete Ontario initiatives. We hope to see you all again in March. Stay healthy and safe. Thank you.
Thank you for everyone who attended, and thank you to the Concrete Ontario Association.
Yep, thanks a lot, everyone.
Have a great day.